Welcome to this latest live virtual weather and climate office hour where, in a tumultuous week, we're just going to talk about the weather. And you might even have some nice background sound effects because here in Boulder, Colorado, currently having a late season thunder shower, so you might hear some booms or hear the background of some rain. Which incidentally is not that different from the background sounds you might have heard in some parts of Northern California over the past few days. Not everywhere, but a fair number of places have seen some substantive September showers and even thunderstorms, so maybe it's a familiar sound for some folks. Before diving in, I just wanted to remind folks that this channel is sponsored by Reask, a climate tech company that's helping companies rethink their extreme weather exposure in a warming world. So it's been a kind of a weird week in California weather by early autumn standards anyway, for a number of reasons, which kind of caps off what has been a weird year overall. A weird summer and a weird winter before it. The weirdness has been in different flavors. Fortunately, in this particular case, it's a relatively benign weirdness where there's been some unusually unsettled conditions, which actually means, ironically, when the weather is unsettled, the wildfire conditions are more settled, which I think is a bit of a relief after last week's major dry lightning episode, which did, unfortunately, take out another very small California town, Chinese camp in the Sierra foothills, but otherwise had the potential to be a lot worse than it was, given the volume of lightning strikes and the number of fires that did ignite. As I talked about last week, we were really lucky that most of that dry lightning occurred over the Central Valley, where any fires that ignite are relatively easy to access because of the road network. They're going to be primarily burning in grass, and there were fewer fires than there would have been simply because a lot of the Central Valley is either irrigated or urbanized, so a different situation there. So you might be hearing that background rumbling or the rain right now here in my background. But also, those lightning strikes last week did not align themselves over the part of California where they would potentially do where they would ignite the most fires anyway. The Coast Ranges, if we'd gotten a bunch more dry lightning there, that would have been a different story. Also, if the most intense strikes had aligned more over the Sierra Nevada, that would have been a bigger problem. But the other piece of context here that's really important is that Northern California is not experiencing a drought at present. That was really the big difference from what transpired, for example, in August of 2020. That was also a particularly extreme lightning event, but the one we saw last week was a pretty big deal, and had it occurred under different conditions, if it had slightly shifted west or east by 30 or 40 miles, and or if there had been a significantly more severe drought, and I think that's really the clincher, then the outcome probably would have been a lot different. We would have seen more ignitions that would have taken off faster and gone to cause a lot more harm. As it is, there was some harm done in that initial 24 hours, but really most of those fires are now either fully contained or even extinguished out cold, which is a pretty remarkable accomplishment given that they did occur right around peak seasonal dryness in late August, early September in a lot of the state. And at least in the southern part of the Sierra, there is a drought ongoing there. So conditions were anomalously dry and warm leading up to that event. So we're somewhat lucky. And I think lucky is a good way to describe fire season 2025, except for Southern California in January, which by some definitions wasn't even part of the current fire season. So how do we define it when it occurs in January? It's kind of in between canonical fire seasons. Obviously, the disaster in Southern California in January was terrible and historic, so certainly can't ignore it. But from spring 2025 onward, the western U.S. has had not a quiet fire season by any means westwide, but a relatively non-destructive one. And I think there's a few reasons for that. One is that the order of events has been somewhat fortuitous, so there have been major, even record-breaking heat waves inland. Not so much in California, but there's certainly been big heat waves. But they haven't been coinciding with either major lightning ignition events or major wind events. So that has helped. So it's been hot and dry in a lot of places, but it hasn't been exceptionally windy or with an exceptionally large number of natural lightning ignitions during the highest risk heat periods. Also, different sections of the western US and Canada have sort of rotated from place to place as having their peaks of activity at different times. So in the Four Corners Southwest, it was earlier this summer. Then across the interior, it was a different part of the summer than the northwestern US is only recently, as well as parts of California. So from a firefighting resource availability perspective, that has helped in that crews can kind of move from one place to the next. Even in a year where resource availability is constrained by, let's just call them exogenous circumstances, it's been fortuitous that the crews that are available have been able to kind of rotate around without having a lot of overlapping need. That's very lucky. It's also been, save for one of the strongest hurricanes on record in the Atlantic, a pretty quiet hurricane season, and there hasn't been a need to deploy emergency response personnel or equipment on the East Coast because there's been no major landfalling hurricanes this year. So again, that's probably, you can chalk it up to luck more than anything else, but it is luck falling on the beneficial side of things, as opposed to the other direction, which is nice to see at least sometimes. The other piece is that in places like California, we've kind of had these episodes of precipitation, including the one this week in Northern California, especially in the Coast Ranges, the Northern Sierra, and even the Northern and Central Sacramento Valley as well, and even a few pockets in the Bay Area, although there it's been more light showers, except unless you were in San Jose, which saw a day of record rainfall. I think it was an isolated heavy shower over San Jose, brought 0.4 of an inch yesterday, which is the most rain that has ever fallen in San Jose on any September 10th on record. It's a little bit of an esoteric record, but it just goes to show you that early September is a very dry part of the year, normally, in this part of the world, and so it's notable to see any measurable precipitation, let alone what we saw over the past few days in some parts of northwestern California, which was in excess of 0.5 inch to an inch. That's real rain. Didn't see that much down in the Bay Area, of course, or down in Sacramento area, and in fact a lot of places remained completely dry or dry but for some brief showers that just made some impressions in the dirt on your windshield. But up north there really was a really solid soaking rain, and that is pretty significant for early September. You know, in northwestern California, 0.5 inch of rain is not very much compared to the 40 or 50 inches of rain in some places that fall in a typical year, but rain this time of year is especially consequential because what it does is it has a big effect on fire season and fire risk. And in northwestern California, where most of the fires that are currently active are burning, or were active before the rain anyway, this has been a particularly well-timed deluge in some places, or at least smattering of showers elsewhere. So that's a pretty good stroke of luck in places that have seen some significant water, and I'll show exactly what that looks like. Again, though, it did not rain in central or southern California, and in fact it has not rained in most of central or southern California for a really long time now. So the good news up in northern and northwestern California does not necessarily extend farther south, and that's in alignment with the general rule of thumb that unless some anomalous tropical rain event occurs really early in the season in Southern California in September or October, fire season usually lasts or even peaks much later down south as you start to see the occurrence of Santa Ana wind events in later in September or October or even into November or December. So talk a little bit about where fire season is seriously mitigated already and where it isn't, because there's definitely some very different patterns depending on where you are in the West and where you are in the state. And the other interesting thing that's, I think, becoming increasingly apparent is just how anomalously warm the Pacific Ocean has become just off the coast of California now, in addition to being ridiculously, anomalously warm all the way across the northern basin from China and Japan, thousands of miles eastward to just off the California coast. That anomalous warmth now extends all the way to the coast in a way that was not occurring earlier in the summer. So now, if you feel that mugginess in the Bay Area, or even along the North Coast, believe it or not, some of the most anomalously warm water is actually along the Humboldt County coast in Cape Mendocino region. Not the warmest water, of course, that's always down in Southern California, where the water temperatures are in the 70s Fahrenheit versus the upper 50s even along the Mendocino coast. But in terms of the degree to which they are warmer than they usually are at this time of year, that is maximized in the parts of the California upwelling zone that are normally coldest. So I'll show that as well in just a few minutes. And that is potentially contributing to why Northern California has been able to be the beneficiary of these showers as this unusual low pressure system has spun overhead over the last few days, and what kind of implications that might have for the rest of winter, fall and winter, really, because I'll talk a little bit about the seasonal outlook to come as well. So I want to dive into some of the graphics now. So hopefully, lately I've been having some issues with some screen sharing, but let me just make sure that you're seeing everything. Yes, it looks like it's the infamous infinite mirror is the correct thing to be seeing first. And then we should be seeing satellite imagery now, so I'm just going to double check that that's actually the case. Yes, looks like it. So it's a pretty benign satellite image of the southwestern California overall. I'll get my drawing tool out and do a little bit of illustration here. Okay, there we go. Let's change the color. Let's go for a dark blue today. So again, most of the California coast is fairly fog-free, low clouds-free. I guess and that's not true of the North Coast. There is some fog up there. And there's some patchy fog, actually, even in the inland Bay Area, but ironically not down on the Santa Cruz or Monterey coast and not along the Sonoma coast. So it's kind of isolated the Bay Area. Central Southern California, there's nothing to speak of now. There's some nice benign fair weather cumulus clouds over the Sierra Nevada and some of the coast ranges right now. So those could develop into isolated showers or thunderstorms later, one more day of it potentially. And you also see this interesting little low pressure spinning kind of, again, from a weird direction, northeast to southwest, as has been the general anomalous flow pattern in recent days in California. But overall, a pretty relatively quiet satellite map. And I'll zoom in a little bit, but it's still, just to emphasize what we're not seeing, is a lot of wildfire activity. In fact, the only fire activity I can sort of tell is there on satellite is, again, the Garnet Fire in the southern Sierra Nevada, and even that looks relatively quiescent compared to recent days. If we flip over into the shortwave imagery, in fact, we see that the heat signature, you can see the residual heat signature from the area that burned, but really that's the quietest heat signature I've seen in some days on this fire. Now, some of that's probably being masked because of smoke and clouds. The northern edge of the fire is still pretty active, and it is going to heat up and dry out in coming days, so it probably will stand back up again sooner rather than later. But right now, well, there's the local radar, apologies. And there's the thunder. There you go, perfect timing. So just for those just joining, we're having a local thunderstorm here in the background as I record this. I'm trying to decide whether I unplug the power cable from the laptop I'm streaming from, although, to be fair, I have so many other cables plugged in, it probably doesn't matter. The other thing I want to show is the rain that fell in Northern California over the past 3 days. This is a nifty tool from the Weather Service at water.noaa.gov. Again, your federal tax dollars at work. This is a precipitation assimilation. Obviously, we don't have rain gauges in every single location on this map, of course. I wish we did, but we don't. So this is an interpolation of radar data and rain gauge data so that you can fill in the gaps between the places where we have actual observing stations. And there's a few things I wanted to point out. First of all, Sacramento and most of the Bay Area did not really see rain from this. There may have been some sprinkles or brief showers, but essentially nothing measurable, unless you were in this region right around San Jose, where, as I mentioned, there was technically a local shower that brought some heavy downpours and a record-breaking daily rainfall, a smattering of under 1/10 of an inch from drizzle or light showers elsewhere. As you get up into the North Bay, though, parts of the Sonoma and Napa Hills, again, not a ton of rain, but, you know, a few hundredths to 1/10 of an inch, still something that's nice to see this time of year. But the more significant rainfall was kind of up in this region, up in northwestern California, up into Oregon, including really the much of the coast ranges from about Lake County northward into Del Norte County and Humboldt County, and then everywhere from about the central Sacramento Valley northward, so that includes Red Bluff and Redding, and then northward into the mountains into the Shasta region, and then the northeastern foothills, mainly above Oroville and Paradise, so they didn't really get rain there, but just above there was significant. And just pointing out the scale here, look, you know, I think the most relevant contour here is kind of the light green. So those are places that saw at least a ½ inch of rain. That's enough to be significantly fire season mitigating. It's not enough to be fire season ending, but it definitely will help out with a lot of the fires, especially since some of those are right up in here in this region that got even more rain, mostly above an inch. But also, you know, helpful up in, certainly in the foothills ringing the Central Valley, which often have significant fire risk this time of year. That's nice to see. That's a pretty good soaking, mostly above ½ an inch there. So really, I think it's fair to say that the dividing line is kind of everywhere within this red region saw some serious fire season mitigating rainfall over the past few days. And then there were some patches within this region that saw transiently fire season mitigating. So sort of up in here in parts of the San Francisco North Bay, down by San Jose, and maybe up along the crest of the Central Sierra. That's maybe 3 or 4 days of offsetting what some of the Weather West blog commenters will call anti-rain. So the evapotranspiration from warm, sunny, breezy conditions. This amount of water in this region, it'll take a couple of days to sort of offset it through evaporation. So it's nice to see, but it doesn't mean that much in a seasonal context down here. But this is enough to be more significant, given that we're probably less than a month out from the next rain statistically up in this part of the state. So this might really be enough to tide us over until that next rain. And if we can get another major rain event up here, that might be closer to season ending. But when it comes to really to the foothills in the Sierra, starting around Paradise, Oroville, moving southward, we haven't really seen any fire season mitigating rain, let alone fire season ending rain. We haven't seen it yet in the Bay Area, and then I'm not even showing the rest of the mass of the south because there was really no rain. So not really any rain in the Garnet Fire region, so higher humidity and clouds have helped, but not, you know, that fire is likely going to pop back up given the long-term drought and dryness once that humidity and temperature, the humidity drops and temperatures rise, which it will. The fires up here might also pop back up because it's heavy timber, but maybe not, and it might take them longer because this is a fair bit of water. So generally speaking, some good news. There were even a couple of flash flood warnings for some of the recent wildfire burn areas for very localized heavy downpours, but I didn't really hear of any real problems stemming from that, so it looks like overall a pretty beneficial event. In keeping with that, here's the update from Watch Duty on the Garnet Fire, which is now getting close to 60,000 acres. You can see this fire is still active, and it is actually still mostly active on its northwestern flank, where there's been a lot of firing operations. This discontinuous line, I'm pretty sure, is a large-scale firing operation to sort of provide some burned area as a barrier when this fire continues to spread toward it. It's going to be a little harder to catch it up in here or down here, but, putting this right in front of the head of the fire is probably going to slow its progression once it picks back up. There is still some activity on the eastern and northeastern flank, although again, once you get up into this region, you start to hit the granite, you start to run out of vegetation, so at the Sierra crest. So, still an active fire, less active right now, but I do expect this one to be much more active again by the weekend, so we probably will see this one stand back up. But that said, the other big lightning fire that was burning for multiple days was the salt fire, not really threatening too many people, and that one is, I believe, considered as contained at this point. So it did burn 25,000 acres, but I think it's a done deal. No large major fires in Southern California. There was an interestingly named one, the tornado fire yesterday, which has nothing to do with tornadoes. But look at how few active fires there are as we go up into Northern California, and notice that most of these larger active fires, all of which were started by lightning earlier in the summer, by the way, the Dillon fire, the Blue fire, the Log fire, all these were lightning fires. A lot of them are now officially either contained. Maybe not the Log fire, but the rest of these are looking really good. So, pretty good shape right now, wildfire-wise, in California. The only really big one that's probably going to keep burning for days or weeks is the Garnet fire. Bigger picture, though, it's not so good, and if you look up into the northwest, interestingly, you can kind of outline the regions that saw significant precipitation this week. So, this is sort of the portion of Northern California and Southern Oregon that saw significant rainfall. So this region in here. Washington saw essentially no rain. Western Washington, northwestern Oregon, this part of the Northern Rockies. So this I should maybe be a little more careful with that. This fire zone is really active and did not get season mitigating rain. So actually, usually it's the case you say, it's probably wetter up north than in Northern California. Not necessarily. Northwestern California got a lot more rain than this region did, and these fires remain very active. In fact, widespread lightning occurred in this region with these weren't really dry storms per se, so they did have some rain, but it was light rain. It was not really heavy downpours, and I think the lightning and the wind aggravated the fires in general more than it extinguished them. So there is still really active wildfire conditions northeastern Oregon, Washington State, northern Idaho, western Montana, and then up into British Columbia, which has just been hitting all types of new all-time temperature records for September up in BC and parts of Alberta, Northwestern Territory. So California's fortuitous luck is somewhat at the expense of other regions. I think it's fair to say California could use a break, but just to point out that fire season is not over. It's most mitigated in Northern California and maybe Southern Oregon. It remains very active up in much of the Pacific Northwest and Western Canada, and could yet be reinvigorated from about the I-80 corridor southward in California. I would expect to see an uptick in wildfire activity again moving forward with the weather forecast. Speaking of which, well, actually, let me back up a moment and talk about ocean temperatures first. Let's take the global view. Yikes. This is a really pretty intense view of the big picture in the Pacific Ocean. And I'm just switching my tools here in the background so I can do the adequate drawing on screen for you here. Okay, let's go with bright pink. So this is the huge North Pacific marine heat wave. Could call it extreme. I think it's fair to call it extreme, and I'll show you why in a minute. As I mentioned, it is most extreme in the far western Pacific, encompassing nearly all of Japan here, the Koreas, and most of the coast of even China, Kamchatka, and Russia, all the way down to eastern China. I mean, it is the extent of coastline that is seeing enormous ocean surface temperature anomalies is very large in this region. But then notably, it extends all the way eastward now. As the season went on, it extended farther and farther east, And as I mentioned, my prediction earlier this summer is that it was going to make it all the way to the California coast at some point, a little bit later than I expected, but it did eventually make it all the way to the west coast, and there is now far above average water temperature all the way from the ocean near Anchorage on Alaska all the way south to really contiguously south to Peru. I mean, if you look at the Pacific Rim coastline, I'm just going to draw it out. The entire Pacific Rim now has warmer than average water temperatures, literally from Southeast Asia, from China to Peru. So this is the entire North Pacific Basin Rim. And really, if you look at it, most of the Southern Pacific Rim too. Look at Eastern Australia, parts of South America. Really, the only segment that's not true of is this emerging potential La Nina signature off the coast of South America. But that is a huge extent. But also look at the numbers. The numbers are really high. The oranges and reds here are 2 or 3 degrees centigrade. So multiply by about 1.8 to get to Fahrenheit. And that's a pretty significant departure from average. I'm going to zoom in on California here so you can kind of see more closely what this looks like. And again, these numbers are nothing to sneeze at along the coast. In particular, remember, see that blob I mentioned off of Cape Mendocino? That's about 4 times 1.8 in Fahrenheit. So we're getting up close to 6-7 degrees Fahrenheit above average. That's really noticeably warm near Cape Mendocino. We get to the Bay Area, we're still 3-4-5 degrees Fahrenheit. Again, these are degrees in centigrade, so you gotta use that conversion factor. Most of Southern California too. A little bit of cooler water along this really narrow strip by Baja, but overall, this is really warm water, and it has continued to trend warmer. Initially, it was near average, then it was a degree above average. Now it's just overwhelmingly quite a few degrees warmer than average, to a striking extent. Hawaii is kind of right on the boundary of this, and you can kind of see maybe an incipient cool La Nina signature down here. But this is something we haven't seen in a while. And some folks are calling this the blob redux, but I challenge you to find a blob in here. This isn't really a blob so much as the whole North Pacific is on fire. The blob was kind of this circular region of anomalous warmth back in 2013, 2014, but this is just homogeneously super warm everywhere. There isn't a real obvious focal point. Maybe there's a little bit of blobbiness here, but it's a sea of anomalous warmth with a weird La Nina-like signature. You can see these instability waves in the ocean forming as trade winds blow like this and cause the water to eddy out from that equatorial flow. So the other thing and this is the NOAA, again, the NOAA Coral Reef Watch product. Here is an interesting way of thinking about this. This is intended to be a watch and warning product for coral reef bleaching. So you can kind of see there's no coral stress versus coral bleaching watch, coral bleaching warning, and then alert levels 1 through 5. So corresponding to the bleaching begins here, and it is like at concerning mass death levels here. There's an awful lot of dark purple on this map. Now, for the marine scientists out there who are yelling at me, there aren't coral reefs all throughout the North Pacific. This is primarily a tropical and subtropical phenomena. That's absolutely true. This map is not intended necessarily to connote that there is mass coral bleaching happening or these colors are bright, because there may not be coral there to bleach. But what this can really be viewed as, I think, is a measure of the degree of anomalousness. So right now, there are big parts of the North Pacific that are level 5 out of 5 extremity in terms of how rare or anomalous this marine heat wave is. Essentially unprecedented in the dark pinks and purple regions. We just haven't seen a marine heat wave that extreme. Also, note what's going on up in the Barents and Kara Seas up here in the Arctic. Also some extreme stuff, with lesser stuff extending all the way now to the California coast is either at warning or alert level 1. Now again, there's not a lot of California, the big coral the big coral growth regions are really further south, closer to Baja, although interestingly there, we actually do also have level 1 or 2 coral bleaching alerts down off of the western coast of Mexico and Baja California. So there probably is actual coral bleaching going on here. And then we have the Caribbean Sea, which is again alert level 1 or 2, so significant coral bleaching probably happening in the Atlantic tropics, and then maybe in the far western Pacific. But the main reason I'm showing this is a really a measure of the extremity. Now this is just a snapshot for this week, but if we look at the sustained product, this is essentially the, let's look at this again. This is heating degree week. So essentially this is saying not just, and you can look at the units, this doesn't mean the ocean is 20 degrees centigrade above average. That would be like a life-altering event for people on Earth. What it means is that if you multiply the magnitude of the anomalies, so say 3 degrees, by the number of weeks, say 5 weeks, you might get a value of 15. So this is a product that's measuring the duration and intensity together of the heat wave. So, 15 is right around here. That means that in this region, off the coast of California, we've seen sustained anomalies that are that large for at least that many weeks. Again, the dark purples suggesting that either the anomalies are very large, the persistence is very high, or both. We now are starting to see this extend all the way to the California coast. So there's a significant oceanic heat wave. In fact, I would even call it an extreme oceanic heat wave now across the entire North Pacific Ocean. Again, it's been strongest in the West Pacific, but recently it's really accelerated near the California coast. And look at the Atlantic. Most of the North Atlantic is also experiencing a relatively extreme marine heat wave. So this is fairly extraordinary in terms of the magnitude and the duration here that we've got going. And just to look back a little bit, I did want to reflect a little bit on the August that we just had in the United States, and this is now that the official numbers are out, this is a divisional basis in California, so nowhere in the western U.S. saw a record warm August, but literally everywhere in the western U.S. saw a significantly warmer than average August. And just to put that into perspective, what does that mean? Well, for different California climate divisions, for the North Coast region, this was the 4th warmest August on record going back to the 1800s. That is pretty significant, especially in a decade where we've seen unprecedented warmth summer after summer. The Sacramento River drainage, the 6th warmest, so not quite as high, but it's still up there well into the top 10. Again here, the San Joaquin drainage still in the top 10, Central Coast, Bay Area. 6th warmest, Southern California not quite making into the top 10, but still in the top 10% of all years in terms of warm August, and that extended throughout most of the West. If we take a longer view, going back 3 months, we do see that California, especially due to that really cool July in some places, ends up a little bit lower rank. So Central and Southern California merely in the top 15 to 25 warmest years. Ironically, in the Central Coast drainage, it was the 22nd warmest summer on record out of about 127 years of record keeping, and yet it may have also been the coolest summer in 20 or 30 years. Think about how strong the warming trend has to be for that to be mathematically possible. But my broader point here is that now we're looking at the 3-month period from June through August this year, so the full summer. Consistent with seasonal predictions, it was much warmer than the long-term average everywhere in the West. More so in some regions than others, so more so in the Pacific Northwest than in Southern California, and more so across the interior West. But this was another, believe it or not, in terms of the long-term context, it was warmer than average everywhere, although notably not record warmest anywhere in the West. So that is also important context. If we look at precipitation, we also see, again, through June through August, that it was a pretty dry summer in most of the West, including the core monsoon region, driest 10% of monsoons on record, and it was also really dry in the Northwest, which doesn't receive a lot of precipitation in summer, but it usually receives some, and this is why the wildfire situation has escalated so much up there. Okay, so what's coming next? Well, right now what we've got is let's see what the best model to show here. I guess it's early in the day, so I can show something different. So we have that low pressure system now. That's what we had this morning, and it's moving away. It's fading. Its influence is going away. A few more isolated showers, maybe an isolated thunderstorm in some parts of NorCal this afternoon, but that's going away. That's going to be replaced by actually pretty strong ridging as we get into the middle of next week. Another significant heat wave in some parts of the west. Likely return of triple-digit temperatures in some parts of the Central Valley and interior Southern California. So it doesn't look like anything record-breaking, but it looks pretty notable, especially as the average temperatures are now starting to slide downward as we get into mid or late September. And so this will be a significant heat wave by mid-late September standards inland. And thereafter, there's some uncertainty, and I'll talk about that. The mean signal is towards more anomalous ridging and warmer than average temperatures, but I'll talk about a big caveat there. So you can see right now, we're near maybe slightly cooler than average in some parts of California for the next few days, although notice that now everything offshore is now constantly above average temperature because of those super warm SSTs that I thought would probably make themselves known later this year, and they now have. As we go into next week, we see, again, that very strong warming trend with some pretty significant heat across Sacramento, San Joaquin Valley, across even coastal Southern California. And unlike earlier in the season, we don't have a really pronounced cool patch in the Bay Area or coastal Southern California or the North Coast. Those nearshore warm SSTs are going to allow this inland heat to equalize with the coast a lot more, so it will be pretty warm and possibly pretty muggy, humid. So humid heat possible next week across a lot of California. Not always what we see in September. And really, as we go out toward late September, a slightly weaker heat signal, but overall, it's looking like it's going to be a really warm 2 weeks. So I hesitate to call this summer. It won't necessarily feel summer-like, but it's going to be warmer than average. We're going to see wildfires pick back up in the Northwest, possibly in the continental interior, and maybe in Central and Southern California too, although probably less so up in far Northern California, Southern Oregon, that's just seen a bunch of rain. But there is something else I want to show. You can see I'm going to bring the precipitation map. So, as I mentioned today, some scattered showers in Northern California won't amount to much, but that's what you see there on the map. Then we got about a dry week ahead of us to come, but then take a look at what's going on in Southern California as you go out about 10 days from now. So take a look at this region here. That's kind of interesting. As they move forward in time, it kind of saturates out. Does this mean that all of California is likely to see light rainfall during this period? No, it does not. This is an interesting example of why the ensemble average, so the average across many members of the same model, is not telling us the full picture. This is not telling us that there's a high likelihood of very light precipitation everywhere. What it's telling us is that something more interesting is happening. There might be a significant chance of heavier precipitation, but also a high likelihood of none at all. Let's see if this map has updated. Okay, it has. So here's what I mean by this, and this has bounced around a little bit over the past couple of model cycles, but this is the same model, the European ensemble that I was just showing, but this is for a point near Los Angeles Airport, so coastal Southern California, and this is the time axis, so left to right is moving forward in time from now to 2 weeks from now. This is the average of accumulated precipitation, but each of these lines are individual members of the same model. Again, these are just perturbed using slightly different initial conditions because we don't know exactly what the real atmosphere looks like. Well, what do most of these runs look like? They look like they either bring sprinkles or nothing. So this is sprinkles, sprinkles. A white bar means completely dry. A few more white bars, completely dry. Sprinkles. But then there's this one. Nothing, 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 and then 1.3 inches of rain. Okay, that's interesting. Then a bunch of nothings, sprinkles, nothings, maybe a light shower, nothing, nothing, sprinkles, light shower, nothing. Slightly more substantial showers, and then, whoa, out of nowhere, 3 inches of rain in LA around September 20th. Okay, that's interesting. Or 0.4 of an inch, the time of year, that's still interesting. So something is going on around here. Another way to show that is to look at the 24-hour precipitation. So look in the window. So again, a lot of white, so really nothing on the horizon at all in this period in any member. So 100% of the members are dry. Most of them are dry past this point as well, but not all of them. Look at this one. Right around September 21st, a burst of 1 inch of rain, or here, a pretty significant burst of 3 inches of rain. So something is happening right around September 20th, September 21st in Southern California. And it's actually more dramatic. The last model cycle was wetter. So look, 12 hours ago, more of these members showed pretty interesting, significant precipitation events in Southern California, either around the 20th clustering or maybe a little bit later, depending on the exact member. But I want to show what that might be from. And this time I'm going to bring up the AI European model because I think it's an interesting one in this context. So this is the artificial intelligence based model, which I have significant issues with, but in this context I think it's interesting to illustrate because here's what it shows. Okay, 7-8 days from now. Okay, well actually, this is the updated version and it doesn't show it anymore, but let me go to the last model cycle and I'll show you what it said 6 hours ago. It showed this remnant tropical system decaying off the coast of Southern California and bringing a fair bit of rain across most of California in about 10 days from now. That was 6 hours ago. Look what it is doing now. Same period. Similar trajectory, but it decays offshore and brings only some light showers to the inland parts of Southern California and nothing else. Very different story. That's potentially the difference between fire season altering or even ending rainfall and some dry thunderstorms to start new fires in the middle of a heat wave. Completely different outcomes, both potentially portended by different ensemble members. Some of these ensemble members would be dry lightning, heat, and even wind, fire weather events. These other members would be like fire. This would be fire season ending. This one would be fire season ending. This one would be fire season ending. But a lot of the dry ones would actually aggravate fire season. So what are we going to get? I don't know. Could be any of these. Now, can I put some odds on it? I think the odds are probably about 8 to 10 to 1 that we won't see a fire season ending rainfall. But that does mean there is about a 10-20% chance of something significant happening in this window, especially in Southern California, but maybe in the northern part of the state as well. So we'll keep an eye on that. Odds are low, but not zero, of something interesting happening in this window due to a tropical storm remnant type event. It would be the season for it. September is the time of year when that would happen, most likely, if it's going to happen, but we'll see. And the last graphic I wanted to show is the seasonal outlook, where now there is a slight tilt towards some potential for weak La Nina conditions this year, but I don't think that necessarily means much on its own. I'll talk a little bit later about the winter, but I just want to focus on the rest of sort of fall. I'll call December part of fall for now, but October, again, this is all of the seasonal models blended together. So the European model, the UK Met Office, the French model, the German model, the American model, the Japanese model. So you can see all of these blended together. And they show this pretty broad axis of anomalous ridging. This doesn't even tell us very much other than that in a warming climate, the rising tide raises all ships in a sense, since it's kind of it doesn't have a lot of spatial structure to it. I guess it does in a north-south sense, so there's more mid-latitude ridging at the expense of high-latitude ridging, which is, I guess, a little bit interesting. We move this forward into November. We actually see now a similar pattern with a big red blob over really most of the U.S. We move forward into December, where there is a little bit more structure to this, although it's not particularly promising. It's quite ridgy over and west of California with sort of a high-low pattern here. That's looks a little bit like the tropical, the TNH teleconnection pattern for those familiar. But this tends to result in ridging here and troughing here, and this can be a pretty dry pattern for California. This is something we saw a lot in 2013, 2014, for example, but it's a little too early to freak out about that. But just as a preview for the winter, this is showing some pretty significant ridging offshore, but then a little bit of a weakness as you get closer to California. So another classic conundrum. If this sets up like this, If this sets up like this along the west coast, that's a very dry winter for California. But if it sets up just a little bit to the west, especially later in winter, as we've seen in some recent years, you could have some colder, wetter systems dive down. I do think it means that the early part of winter is likely to be drier and warmer. I'm not so sure that that means the same thing for the second half of winter, though. And I'm also not sure that we really have very good predictability, so I'm going to leave it at that for now for winter. But the other thing I wanted to show, and this is maybe more interesting, is if I look at the 850 millibar temperatures above the surface, so this is the lower atmospheric as I click through temperatures, not the surface temperatures, but the temperatures a couple thousand feet off the ground, which is kind of what you look at when you're looking for heat waves. This does show more blobbiness right over California in October. This is a pretty strong heat and ridge signal, offshore flow signal even, for California during autumn. So that's something potentially to look out for next month. Similarly, November, these are really anomalously warm temperatures over much of the west, but again, there is some spatial structure to it where it's more anomalously warm over California than, say, the Pacific Northwest or Alaska. And as we go, with this model's prediction into winter, we just see, now there's actually some blues on the map, so this is pretty indicative of sort of a high, low, a high kind of pattern. And again, the question is, if the flow pattern looks kind of like this, that might not be so bad for California. But if the flow pattern instead looks like this, well, that's terrible for California. So the question is the ridge axis essentially, is the ridge axis going to be more like this? So let me draw that again. Is it going to be more like this? And so California stays pretty high and dry, or is it going to be a little bit further west? I didn't draw that very well. Let me do that one more time. Is it going to be more like this, with California kind of being under the major ridge, or is it instead going to be farther to the west, and California will actually be just east of the ridge, and it'll be the beneficiary of systems dropping down? Or if they drop down to the east, that's just heat and wind and fire weather. I don't think we really have an ability to see that out at seasonal scale, but that's kind of what this general pattern would imply about the winter to come. I'm not even going to show the precipitation maps right now because those are entirely dependent on which of those ridge axes I'm talking about. But right now, suffice it to say, warmer than average. This fall looks like a slam dunk between and even warmer than the recent warmer average, to be clear. Given the really warm nearshore coastal temperatures, I don't see those going away anytime soon. And also, given the large-scale pattern is expected to be favorable for ridging into October and November, especially across central and southern California, I think fire season's not over yet. So it's great we got that rain up north, because that's really going to help with what might still be in the cards. Okay, so I'm going to go back to sharing my face here, and you're going to see me back full screen, and I'm going to take some questions. So I'm going to start at the beginning, as I always do. Mary mentions that in Medford, according to the NISA up there, it's pouring there, so that is indeed good. Yeah, Southern Oregon doing better than Northern Oregon or Washington, actually, so this is kind of that weird system. Mary also reflects that fire season isn't a useful concept for California, for the most part, at least not to the extent that we stop being vigilant. I do tend to push back on this notion. I hear this a lot from a lot of people, including from some journalists, and this headline that there is no fire season anymore. I understand what folks are getting at, and it's definitely true that fire season is longer in more places and sometimes re-emergent at unusual times of year than it used to be. That's true, but we still have a fire season. If you had to pick a month that you thought that fires would be most active in California, and you were to pick August or September versus January or February, you would almost always be correct. In fact, I think the only year where that might not actually have been true was literally this year. So it definitely means that there can be exceptions, but there is still very strong seasonality to fire season, even as it expands, even as it lengthens, even in years where there are active fires year-round, straight through winter, as was the case last year in California, this past year, there's still a seasonality to it. We still see more fires, and usually more intense and more concerning fires in late summer, early fall in California. That tends to be the peak. It can shift around a bit. We can see devastating fires at unusual times, as we saw last January in Southern California. But I do think we still need to be thinking about the seasonality, because the seasonality of vegetation dryness and how it overlaps with the seasonality of strong, dry offshore winds and how that overlaps with California's precipitation seasonality ends up being really important. And California has a really strongly seasonal cycle of precipitation, to the extent that, again, it's genuinely newsworthy when there are scattered showers, as there have been this week in September. It literally makes the news when it rains more than 1/10 of an inch in much of the state this time of year, because it's so unusual, because of that really strict underlying seasonality. So, to be clear, I totally get it, and we do have a shifting seasonality and an expanding seasonality, but there is still a fire season. And I think what maybe is more to the point is that you can have really dangerous fires outside of fire season. So there can be a fire season, and yet there can still be devastating fires outside of it. And we've seen that in Southern California in recent years. We've seen it in Colorado. We've seen it in other parts of the country where fires are incurred at unusual times of years during periods of severe drought, which we know are increasing due to a warming climate. Even in places that aren't getting drier on average, the droughts are generally developing faster and becoming more intense. And so we can, potentially it means we see more surprises. We may see more extreme wildfire conditions outside of traditional fire season. Most years it's still going to be closer to what we would have expected, but there can be really critical exceptions to that, 100%. Matthew mentions over half an inch of rain around Greater Humboldt Bay, which is consistent with that Weather Service map. Yeah, there's a comment from Eastern Sierra Skies. No Southern California rain since 100th in early May. There are, of course, some regions that saw some rain earlier this summer, but there are also definitely other places in Southern California that have seen literally nothing since May. So, May to September is not that unusual in some parts of Southern California, but, as this goes on, it starts to become a really long period, especially given that last winter was also dry in Southern California. Susan B asks, how is the ocean temperature tracked? Well, most of the stuff you saw on the maps is from satellite imagery, which can read the near surface temperature of the ocean from satellite reflectance. It can't really get the deep ocean as you might expect. We don't have deep ocean penetrating radar or something. The water is pretty dense. There's also sort of quality control by buoys, so in situ temperature probes on floating buoys out there in the water. Some ships which will do drop thermometers into the ocean, take some opportunistic readings. And along the coast, like along the immediate coast in California, we also have essentially temperatures that are fixed, thermometers that are permanently fixed in place at piers and places like that to measure the water temperature there. So it's mostly satellites of most of the spatial area of the world, but the closer you get to population centers and coasts, there's more actual thermometers in there as well, in the form of buoys and etc. Good question from Matthew. Do you think that when the Pacific being as warm as it is means that when it does rain in California, it could rain with a lot with flooding issues? So this is an interesting question, and as I was talking, I thank you for bringing this up. I meant to bring it up when I had the ocean temperature map up. When the ocean temperatures are warmer than usual in a sort of a spatially uniform sense. So remember how the whole North Pacific Ocean is really warmer than average, not just some specific part of it, the whole basin, north of about Hawaii, so north of the subtropics. Think about how ocean temperatures generally trend with latitude. So, the warmest global oceans in general, they get warmer the closer to the equator you get, right? The warmest oceans, the tropical oceans near the equator, are warmer than, the Arctic Ocean. That's the obvious contrast. And there's some pattern of decrease between warm tropical oceans and the sea ice in the Arctic, right? So it's got to decrease from tropical warmth to Arctic frozen water, over the course of some thousands of miles as you go from the equator northward. The rate at which that occurs in a latitudinal sense, so the degrees of change per degree latitude of gained, essentially, is part of what sets the surface temperature gradient in the atmosphere immediately above the ocean. So you might imagine that the ocean surface temperatures are pretty close to the temperature of the air just above the surface of the ocean, and that they are at least somewhat related to the temperature of the air at higher and higher levels above the ocean to a lesser and lesser degree. So essentially the influence of the surface ocean temperature is really strong. In fact, the near surface air temperature in the first 6 feet, so if you were standing on a little ocean craft, is pretty much the same as the water temperature. But as you start getting up, tens of feet up, it starts to decouple a little bit. As you get hundreds to thousands of feet up, there's still an influence where warm water means the air is warmer. But in general, the higher you go in the atmosphere, the less the influence of the ocean as you get farther away from it. You're up 10, 20,000, 30,000 feet, you're largely uncoupled from the ocean. But the thickness of various atmospheric layers is directly proportional, this is Meteorology 101, to the average temperature of all the layers of the atmosphere below it. So we often talk about this technical term called the 500 millibar geopotential height surface. It sounds complicated, it is kind of complicated, but it's actually, what it really just means is how high is the level of the atmosphere where half of the mass of the air is above you and half is below you. 500 millibars because the total mass of the atmosphere is a little above 1,000 millibars. So you're essentially at the halfway point. And that's dynamic. It's not fixed because air moves around. High and low pressure literally means more air molecules in the air above your head. It's literally heavier temporarily. Or low pressure means it's lighter. There's literally less weight on your shoulders if you're in the middle of a low pressure system. So this is dynamic property. The height of that half mass layer of the atmosphere, it wiggles around a lot. Geopotential heights being high, the reason why that corresponds with ridging and warm temperatures usually is because it means that the layer of the lower half of the atmosphere is warmer than average. By definition, geopotential heights scale with the average temperature of the atmosphere below that level. So it's saying that the lower half of the atmosphere is warmer than average. The reason I'm raising all this in the context of ocean temperatures is the jet stream, that river of high velocity air in the upper atmosphere that defines the storm tracks. We're talking up at jet aircraft level, 30,000 feet or something. That is driven by essentially a balance known as the thermal wind, which is a little bit tricky. I won't get into the details, but essentially it has to do with these different thickness levels of the atmosphere and how they change with latitudinal distance. So essentially, as you shift the thicknesses of the atmosphere near the equator and near the poles relative to one another, you affect where the jet stream is and how strong it is. Now, if one of the influences on the thickness of that lower level of the atmosphere is how warm the ocean is, well, then ocean temperatures probably relate to the jet stream, at least in some indirect way. In fact, there's lots of research that shows this is true. But it also turns out that the rate of change of ocean surface temperature affects, as you might expect, the rate of change of temperatures in the air above the ocean, and therefore the slope of this thermal wind, and therefore the position and the strength of the jet stream. Known essentially from this is known as the SST front, essentially. Talk about cold fronts, warm fronts, those are atmospheric locations where temperature changes rapidly. You can get the same thing in the ocean, where there's a region where there's an increased gradient. So usually when you have a strong change of temperature with latitude in the ocean, so it cools quickly with latitude, it's really hot at the equator and really cold to the north, you have a strong SST, sea surface temperature front, which contributes to a strong temperature differential in the overlying air, as you'd expect, transitively, and then that contributes to a stronger prevalent jet stream. But the reverse is also true. If you have a really weak gradient, a really weak differential where the temperature does not decrease very quickly with latitude, then you have a weak jet stream or a displaced one. The jet stream tends to occur over parts of the ocean that have really strong temperature differentials. What we've got right now is a remarkably weak temperature differential across the North Pacific. Because you can imagine The tropics are warm, the Arctic is cold. But we have anomalous warmth in the subarctic and the mid-latitudes, and no anomalous warmth in the subtropics and the tropics. In fact, it's actually cooler than average. So we cooled the warm spots and we warmed the cool spots. We flattened out that gradient and are closer to equilibrating it. What might that mean for the jet stream this fall and winter? It might mean it will be weaker because that differential is less. It might be shifted poleward, northward, because the SST front now no longer exists in the subtropics. It's at a higher latitude. So that's a lot of meteorology, atmospheric, ocean dynamics, mumbo jumbo perhaps. But that means that from a storm track perspective, we could potentially be in trouble this winter along the west coast. We might have a weaker jet stream and it could be shifted farther north. That's not great news if you like rain or snow in California. However, the flip side of this is that if you have an ocean that's 3, 4, 5, 6 degrees Fahrenheit warmer than average, that's a huge amount of additional potential evaporation. So the air probably is going to have a lot more moisture in it, a lot more water vapor than it would have otherwise. If we do get storms, even if it's fewer than usual, they're probably going to have more moisture to work with than usual. There may be some increased atmospheric instability because you add moisture and you increase the temperature of the surface level of the atmosphere, you can get those bubbly cumulus clouds that we've seen recently more easily. I think that's part of the reason why we've been seeing what we have the past couple of weeks. So there's these competing effects. It becomes a higher stakes game. It makes it harder for storms to reach California potentially, but if they do reach California, they have more moisture to work with. So hypothetically, that could mean fewer but more intense storms, not unlike what we expect to see in the long run in a warming California climate. So will we actually see that this year play out? It's hard to say because that's just one, as usual, of many factors at play. It might accentuate it might allow La Nina to punch above its weight in a sense, because La Nina, the cooling of the eastern tropical Pacific, mainly exerts its effect by affecting that surface ocean temperature differential. But we already have a pattern that's accentuating or de-accentuating, as the case is, between the tropics and the mid-latitudes. La Nina would further add to that, and the existing pattern might sort of be additive on top of that La Nina effect. So I'll talk a little bit more about that later. I realize this is a really dense technical explanation of some processes that are frankly not all very well understood even by scientists today, but there's some interesting dynamics at play. I don't think we've ever had a North Pacific as homogeneously, anomalously warm as it is, literally from China to Baja California. The entire North Pacific is highly anomalously warm, and that is going to have a different effect than just having a patch of it warm. Exactly what effect it's going to have, I'll continue to talk about it, but it is a pretty unusual year for sure, especially given that we may have, on top of that, potentially at least a weak La Nina. So I realize I'm past the hour now. I'll be wrapping it up shortly. But I'm just taking a look at the rest of the questions coming in. Yeah, as a comment from Leor about how that there are some spots in the Santa Cruz Mountains that received some significant precipitation this week. Again, this is an assimilated radar and official precipitation gauge map. It's going to miss localized downpours, and a lot of the downpours that occurred this week were very localized. Think about what happened in San Jose. Record rainfall for the day downtown, and then nothing in the suburbs. So it just might have been in between the official gauges in a place where the radar beam doesn't have great coverage over places like the Santa Cruz Mountains. So it's not the be all end all. That map was mostly intended to be a if you squint at it kind of map. Again, that precipitation map is generally representative. It's never going to be exactly right at any given location. It cannot capture localized downpours like that in most cases, unless they happen to fall over an official rain gauge. But in general, it gives you a sense of where it rained meaningfully and where it did not. Obviously, there's some exceptions. There's some folks commenting about the Garnet Fire and that the Tea Kettle experimental forest was largely destroyed. That is consistent with my understanding. The big sequoia grove did have some fire that got up into the sequoia canopy despite some really aggressive efforts, including like setting up sprinkler systems at the base of the trees. And however, I don't think this is the same situation as back in 2020 when there was a high-intensity crown fire. From my understanding, what happened was some of these giant sequoias may have burned from the top down, so there was spotting of embers across control lines. The base of the trees had actually been watered with sprinklers, but the tops of the trees were sufficiently dry, and the fire was of sufficient intensity that it sent embers into the canopy in the giant sequoias, and there was significant fire that burned from the top down, which is a little bit unusual. It does mean that most of the sequoias probably survived, which is different than in 2020, although I haven't seen official reporting, and that even some of the sequoias that may have burned significantly may too survive, because I think preventing the homogeneous high-intensity crown fire was helpful, and having the trees essentially being directly irrigated from sprinklers during the fire helps as well. But it was a little bit surprising that the fire was so aggressive and trying to spread into the sequoias. Apparently there was a deployment of specialized smoke jumpers, really tree climbers, who were climbing into the canopy of these giant sequoia trees to extinguish them one by one once the canopies caught on fire, which is an incredibly dangerous job. It's a very unusual role. Usually there's not that much effort paid to saving individual trees in the forest. Literally, there's more effort in seeing the forest for the trees, but in this case, the individual trees were of significant ecological and cultural importance, and so there was a lot of effort paid to saving, this grove, which had a few hundred individual trees of significance in them. So I think that was an effort that was at least partially successful. I don't think it's the same story as 2020, but the fire did make it into the grove and did burn some of the trees, so I'm waiting to hear more details on that. Yeah, comment that Japan has experienced its hottest summer on record this year by a huge margin, just obliterated the previous record. Not surprising, given that it was surrounded by ocean that was like 5 to 10 degrees Fahrenheit warmer than average. That's a huge number for ocean. Yeah, there's a comment about Chinese camp. CAL FIRE finally updated its damage map, and it does look like about 2/3 of the town structures were destroyed. About 1/3 of them were not. It's my understanding, in that fire, the lightning fire. I guess it was only last week. So that's my understanding. Again, it's a pretty small community. I think today it has fewer than 100 permanent residents, but that's still a community, and it was a fairly historic one, and a number of those historic structures burned. So it's a small community, but it does represent another California community largely overrun by a wildfire over the course of just a few hours. Leor says that the data just shown, this is probably the temperature maps, smooth over the cool summer in the Bay Area, which was, even by historical standards, was cooler. There is some smoothing. This is not capturing the immediate coastal strip, that's true. But I have to say that even the coastal Bay Area, I know it was really cool by the standard of the last 30 or 40 years. That's still a warmer than average summer in the context of the last century that we've been keeping records. That's just how much things have warmed. So yes, it's true that the immediate beaches and coastal strip were cooler than those broader climate division maps showed there. Yet it is also true, again, that that's still warmer than the long-term average, believe it or not. It's just that it can be the record coolest summer in a 30 or 40 year period and still be warmer than average. That's how quickly our climate is warming in places that have seen some genuinely notable coolness, at least in the recent context, this summer, which was true of the Bay Area coastline because of that really cold upwelling we saw earlier this summer that has since dissipated, and so August was not really cool. And also, that's part of why the summer overall wasn't as anomalously cool, because August, we got rid of that really cool water along the coast. The beaches were actually unusually warm for most of August then, as other folks have reflected on people swimming off of Cape Mendocino, an ocean that was not bitterly cold. That's not typically what you'd see. So yes, in June and July it was, but in August it wasn't, and that does, and it's also another testament to just how different conditions are along the immediate coast versus even 5 or 10 miles inland sometimes in California. Again, I've gotten a lot of hate mail in recent days from a variety of sources, but most of it is focused on how angry people are that this summer was not extremely hot along the California coast, which I think is interesting in the context of differentiating between what is even possible to predict. We cannot generate seasonal forecasts for the California coast and distinguish them from the far inland parts of California in any clear way. We do not have predictive models that attempt to do that, so we generally don't make those kinds of forecasts. We're not good at predicting the near coastal upwelling or lack thereof, depending on that, because we do not have operational predictive models that are really calibrated to do that. We could, hypothetically, but for whatever reason, we haven't invested in those. So we don't really have the ability to predict that cool coastal upwelling, or when it does or does not occur to a high degree. So we don't really have the ability to say we're going to have a warmer than average summer everywhere but the immediate coast in California, which is, again, that is what happened this year. I promise you that's real. I'm not making up the data. I promise. But it was very different along the immediate coast, and we don't really have the ability to predict that right now. It was obviously very consequential if you live along the immediate coast, especially from late May through late July. Again, it flipped in August for everybody, essentially. But it was, July was pretty notable for how cool it was, and how cloudy it was, and how cold the ocean was. But, and there was some luck involved too. We did have that increased trophiness, which was more than just the near coastal zone. July was cooler than average almost everywhere in California. But June was really warm across most of California. August was really warm across all of California. So a lot of folks are really looking to July when summer is, in fact, a 3-month period. And so if we're taking a 90-day average, we do have to consider the first 30 days and the last 30 days, as well as the middle 30 days, too. And again, the coast had a very different summer. And I showed that last week. If you want to see the data that's more finely resolving the much relatively cooler, anomalously cool temperatures along the immediate coast this summer, check out last week's live stream, or the week before, or the week before that, or the week before that. I talked about it in each of those sessions. So there's data up there. Or the most recent several Weather West blog posts. You can find the more fine-grained data that does illustrate that there were some places that had their coolest summer along the immediate coast in 30 or 40 years. That was not true for like 70 to 80 or even 90% of California. That's just the way the landmass maps out. Well, I'm glad some folks appreciated the more in-depth dive into the coupled ocean-atmosphere dynamics that might be at play this fall and winter. All right, so I think right now, enjoy the pretty balmy weather in California. It's warmer than average, but not super hot. There's more humidity than usual, so once it heats up next week, it might even be a bit uncomfortably humid, but you got a few more days. Well, now it's just near average temperatures, above average humidity, and below average fire risk. So with really pleasant water temperatures at the beaches compared to what would usually be the case. So that's kind of striking. So get out there and enjoy it. Glad we were able to talk about the weather today. And I'll talk about the season to come a little more later. But I will be keeping an eye on that potential for heat wave next week. It seems pretty likely. Triple digits returning some places. And then that slight chance of some tropical remnant moisture in Southern California thereafter. There's about a 10 or 20% chance of a pretty interesting weather event, so we'll see how that goes. 7 to 10 days from now, there's maybe a 10% chance of some real downpours in Southern California. 70 or 80% chance it won't happen, but 10% is higher than usual this time of year, so we'll see how that goes. All right, until then, I'll see folks next time.